Okay, going back to Friday's lesson. If you weren't here, make sure you go back and watch that video on Canvas. So this is the difference of squares. So let's recap the rules for difference of squares. For it to be difference of squares, it has to be subtraction. Both of the numbers have to be perfect squares. The exponents have to be even. So this is the difference of squares. So this would factor down to, you would make you don't need to, you would just go straight to your parentheses. So what multiplies to be x squared is x times x, that would go on the front. What multiplies to be 64, the square root of 64 is 8 times 8, that would go on the back. One has to be plus and the other one has to be minus. That's a pattern that you should recognize by sight. So now that it is factored, you can set each factor equal to 0. And solve them both for x. So your two solutions would be x equals -8 and x equals +8. Any questions about how we work through that? So number 2 is not the difference of two squares. Okay, it is subtraction and 36 is a perfect square, but 2 is not a perfect square. So this is not the difference of two squares. So this is not the difference of squares. So we are not going to factor it. This is not factorable. Now, even if we take out our greatest common factor, and what is the greatest common factor? What can I divide both of these by? By 2. If I take out that 2, I'm still not left with the difference of two squares. Because 18 is not a perfect square. Okay, so let's just solve it. So in order to solve it, I want you to take this parentheses, which is x squared minus 18, and I'm going to write it over here so that everyone can see it. So take the x squared minus 18, set that equal to 0. And let's solve that for x. What would be the first step to solve that for x? So that would give you x squared equals +18. And how do you get rid of that exponent? The square root. Good job. So x equals the square root of 18. Now, anytime you take the square root, and we're going to talk about this today, it's always two answers. It's positive and negative. There are two numbers, okay? Now, 18 is not in the box. It's not a perfect square. If you look on the board, that's not a number that is a perfect square. However, do we have a number in that list of perfect squares, in our list of perfect squares, that will go into 18? 9. 9 is a factor of 18. And 9 times what is 18? So we're going to actually break this apart to plus or minus 9 times 2. So 9 is a perfect square, and the square root of that is 3. So this would be your final answer for that second question. Okay, so take out your rebuild book. And go to page 173. 173, I believe it is. Let me see. 173. So going back to what we just talked about, whenever you take the square root of a number, so for example, when we look at this, the square root of 49 is actually 7 and negative 7. Okay? So there's two answers every time you take the square root. When you take the square root of a number, it's positive and negative. And the reason for that is because if you take 7 and square it, you get 49. And if you take negative 7 and square it, you also get 49. So that's why when we write our solutions, we put that plus or minus in front. Going back to the bell work that we just did, notice I put a plus minus in front because there's always two solutions when you take the square root. So for the square root property, which is what we're going to talk about today, if x squared equals n, x is going to equal plus or minus, and that's the key word. It's two solutions. It's always two answers. One answer is positive and the other one is negative. So the square root of 121 is positive 11 and negative 11. It's positive 11 and negative 11. Except we don't usually write it as two answers. Sometimes we just put the plus minus symbol to show that it's two separate answers. Okay, so let's look at example 1. We're going to walk through how they did this. So they solved it using the square root property. So for the square root property of solving an equation, we have to do some factoring. So what they did was, looking at this example, they factored this down. They factored the left side down. So remember, because a is 1, we could do a shortcut. So we need two numbers that multiply to be 4 and add to negative 4. So negative 2 times negative 2. So this box, go ahead and put a box around that. That factors down to x minus 2 times x minus 2. That's what that factors down to. But in math, whenever you have something that is multiplied against itself, instead of writing it twice, we write it as x minus 2 squared. That's why this is written as x minus 2 squared. So does everyone see how they got from here to here? Okay. So x minus 2 squared is the same thing as x minus 2 times x minus 2. So now to get rid of this square, they took the square root of both sides. Go ahead and put that square root symbol. Now, when you take the square root of this, it just eliminates the parentheses and the exponent. So it just becomes x minus 2. So x minus 2 equals, and you see how they put a plus and minus the square root of 25. So what is the square root of 25? 5 and negative 5. Okay, so this is where it's kind of confusing. I'm going to go ahead and break this apart. So what they did was they separated this into two equations. So your first equation that you're going to solve, go ahead and write off to the side, is x minus 2 equals 5. But then your second equation is x minus 2 equals negative 5. That's what they're doing down here, except down here this kind of looks confusing. So what I want you to do is just kind of ignore these two, because I think that might be a little confusing. At this part here, we're going to break it apart into two separate equations. So we have x minus 2 equals positive 5, and we have x minus 2 equals negative 5. So how would you solve this equation? If x minus 2 equals positive 5, how would you solve this? What would you do? Add the 2. So your first solution is x equals what? 7. Put a 7. And again, for the other equation, again, you're going to add the 2. And -5 plus 2 is -3. So that's how they got the two solutions at the bottom. 7 and -3. All right, you may need to, I don't know if you have enough space, but we need to do, I want you to do that check at the bottom of page 175. I'm sorry, 173. So I am going to work that out with you. So let's look at that one together. So the check that's at the bottom of page 173, it says solve, and it says x squared minus 38x plus 361 equals 576. Okay. And they want us to solve it using the square root property. So first thing we want to do is we need to factor this down. And the test to see if this is a perfect square, this is the test, and we're going to talk about this again in a little bit. I want everybody to take your calculator, take this b, and divide it by 2. Because if b divided by 2 squared equals c, and I know this, the way that's written, that looks really confusing, but it's really not, I promise. So in your calculator, I want you to take -38, because that's b, divide that by 2. What do you get? Now take -19 and square it. And when you square it, remember, you have to put it in parentheses. Did you get 361? Yeah. So anytime b over 2 squared equals c, so you see how we took this, divided it by 2 and squared it, and we got that? That means that this is a perfect square. This is a perfect square. So this would factor down to, let's make our 2 parentheses. So the two numbers that multiply to be -38 and add to 361 is -19 and -19. So this is what this factors down to. It's another pattern. So we're talking about a perfect square pattern. Except in math, whenever it's the same factor, we don't write it twice. We're going to write it as x minus 19 squared. Okay. So now, how do you get rid of that exponent? The opposite of a square is to take the square root. Let's take the square root of both sides. Now 576 is a perfect square. Go ahead and type that in your calculator. I believe it's 24. Is that right? So remember that this is plus and minus 24. So we have x minus 19 equals positive and negative 24. So let's go ahead and separate that into 2 equations. Your first equation is x minus 19 equals positive 24. Solve that for x. And your second equation is x minus 19 equals negative 24. Go ahead and solve both of those equations. So this is how you use the square root property. So if you have this green box, if this is true, then it is a perfect square. And we're going to do a lot of that between today and tomorrow. So your first solution, when you add 19, that would be 24 plus 19, which is 43, I believe. Okay, x equals 43. And your second one, when you add the 19, is that negative 5? Yeah. That would be your 2 solutions. Okay, so now let's look at example 2 on page 174. So we're still going to do the square root property, except now this means that it's not, the answer is going to be a decimal. It's not going to be a whole number. So again, use your calculator because you can test this. If you take 24 divided by 2, what's 24 divided by 2? And what's 12 squared? So do you see how half of this number squared equals C? That means that this is a perfect square. So this here, that green box factors down to x plus 12 times x plus 12. But instead of writing it twice, we wrote it with an exponent, x plus 12 squared. So the next step was to take the square root of both sides. So that was the next step. Now this number is not a perfect square like it was in our last example. In the last example we had a perfect square. But we always look in that box to see what number, what perfect square can go into 192. So the perfect square that divides into 192 is 64. Go ahead in your calculator. Take 192 and divide it by 64. And you should get 3. Did you get 3? Okay, so this can also be written as this. So the next thing we did was we took the square root of 64, which is 8, and the square root of 3 we had to leave. So this is how we got from here to here. We simplified this radical and we got 8 root 3. So the last step is going to be, because we didn't get a whole number, is to just subtract this 12. When you subtract the 12, this 12 moves to the other side. It becomes negative 12. So you can write your answer. You can actually leave it just like this and say x equals negative 12 plus or minus 8 root 3. Or you can break it apart and write it as 2 separate answers. So your first answer would be negative 12 plus 8 root 3 or negative 12 minus negative 12 minus 8 root 3. Now, if you type this in your calculator, it will give you the decimal form, so we'll focus on that a little bit later. The main thing I want to make sure you're able to get to is this is the exact answer, and that would be this right here. Any questions about example 2? I don't know if example 2, let's see. All right, let's go ahead and look at example 3. So for example 3, the first step they did was divide everything on the left by 2. Not everything on the left. They divided the entire equation by 2, sorry. So every single term was divided by 2 to achieve that perfect square. So that was their first step. So that's why this became just an x squared. 92 divided by 2 is negative 46. 1,058 divided by 2 is 529. What's negative 72 divided by 2? Go ahead and use your calculator if you need to. Negative 72 divided by 2. So let's fill in that blank. Negative 36 will go here. So now let's test this theory. Let's see if this is a perfect square using that definition that I just gave you. Take this number right here, divide that by 2. So if you take this number and divide it by 2, what do you get? And what's 23 squared? 23 times 23, do you get 529? Yes. So this here is a perfect square. So what I have in yellow, that can actually factor down to x minus 23 times x minus 23. It's a perfect square trinomial. Anytime b over 2 squared is equal to c, it is a perfect square. So we have x minus 23. That would go here. Put your 23 here. And now we're going to take the square root of both sides. So let's take the square root of the left. Let's take the square root of the right. Now, when you take the square root, this is going to eliminate the parentheses and the exponent, and we have the square root of negative 36. So let's pause here. What did I tell you? Anytime you see a negative under a radical, what do you have to do with that negative? You have to take it out. So let's break this apart to negative 1 times 36. And what is the square root of negative 1? I. And 36 is a perfect square. And the square root of 36 is 6. So that's why on this blank here, we're going to write 6i. That's how we got from here to here. So we have x minus 23 equals plus or minus 6i. The last step, because you have to solve for x, and because that's a negative 23, you're going to add the 23 to the opposite side. So there's going to be a positive 23 here, and this is your final answer. That would be your final answer. You don't need to separate it into two answers. You can leave it as one statement, 23 plus and minus 6i. Or you can break it apart, that's optional, to 23 plus 6i or 23 minus 6i. Now, when it's imaginary, you cannot write it in decimal form. All right, let's look at it. That is the end of part 1 of our lesson. Now let's talk about completing the square. So let's go to page 175. Completing the square. So sometimes it is incomplete, so we need to find the C value. Find the C value to create a perfect square. So that's what we're talking about now. So in other words, we have something missing. There's a missing term, and we need to figure out what that number has to be in order to create a perfect square trinomial. And it's actually very simple, because we know the rule is it has to be half of b squared. So what we're going to do in order to create our perfect square trinomial is we're going to take half of b, square it, and then add it to the result. Those are our 3 steps. So let's look at example 4. Almost finished for today. And then you'll have time to work on homework and to get tutoring and get additional help. Okay, so this is our trinomial right here. And it's incomplete because see how they left that last number off. We need to figure out what is that number. What's the number that I can put there to create a perfect square? So in order to do that, the first step is going to be to take half of negative 7. So negative 7 divided by 2 is negative 3.5. The second thing I want you to do in your calculator, and make sure when you type it in your calculator that you're including the parentheses around that negative. So take negative 3.5 and square it. It is going to be a decimal, and that's okay. So take 3.5 squared. And you should get 12.25. Who got 12.25? All right, so now we figured out that the missing number here in order to create a perfect square is 12.25. So we're going to write that x squared minus 7x, and it's always plus c, plus 12.25. This is a perfect square. And the reason why it's a perfect square is because it follows the rule of b over 2 squared equals c. Anytime this is a true statement, it is a perfect square trinomial, which means that this can factor down to I'm going to write it. This factors down to x minus 3.5 times x minus 3.5, which can also be written as x minus 3.5 squared. It is a perfect square trinomial. All right, so now let's go ahead and look at example 5. We're going to solve this by completing the square. So this is a completely different method from the square root property. So I know there's a lot of different methods that we are covering, but this is not the same. This is different. So now we're talking about solving by completing the square. So whenever you solve by completing the square, your first step is going to be to add the C value. So that C value, or I should say not add it, because if it's positive, you would subtract it. So we're going to say move C. So this C value right here, we have to move it across. And that's why we got here. So that -4 is going to move across. So now we need to add, we have to figure out the number that would go on both sides. And to do that, see how it says you're going to add b over 2 squared to each side. So what is b? So what's b divided by 2? 9. And what's 9 squared? 9 times 9 is what? 81. So I want you to add the 81 to both sides. Because what we're doing is creating a perfect square. So when we look at this right here, this is a perfect square trinomial. X squared plus 18x plus 81 is a perfect square because half of b is 9 and 9 squared is 81. So this part that I have highlighted in yellow, that is actually going to factor down to x plus 9 times x plus 9. That's what that factors down to. So it becomes x plus 9 squared. And that equals 4 plus 81. And what is 4 plus 81? What's 4 plus 81? 85. Good. Put your 85 right here. So now you're going to take the square root of both sides. $85 is not a perfect square and it cannot be simplified. So there isn't a number in this box that will go onto 85. So we're just going to leave that as 85. So your last step, notice we put the plus or minus in front, is to subtract the 9. So this is 2 answers written as 1 answer. That would be perfectly fine. Or you can separate it. And if you separate it, you would get -9 plus the square root of 85 and -9 minus the square root of 85. Okay, so if you were to write that as a decimal, the square root of 85, what's the square root of 85? I know it's 9 point something. 9, okay, so 9.22. So this is, if you were to, in your calculator, if you were to take x equals -9 plus 9 point, what did you say again, Deshaun? 9.219. So we'll say 9.22. So if you take in your calculator, go ahead and add -9 plus 9.22. And if you do the same thing and take -9 minus 9.22. That's how you would get your 2 answers in decimal form. Now, this is the best answer because I had to round this because the square root of 85 is irrational. So I had to round it. So -9 plus 9.22, what would that give you? 0.22? And what did you get for the other one? What's -9? -9 minus 9.2 is -18.22. So these are your answers written as decimals, and this here is the exact answer. So we did do a lot today. We started 2 different methods for completing the square. So I am going to go ahead and put up homework 19, but several of you have not turned in 15, 16, 17, and 18. So that's where you really should put your energy right now. I know I do take homework up until the day of the test, but waiting until then is too late. Because you want to understand the material to ensure you do better. So don't wait until the end, okay? So I am going to put up this homework, but several of you, again, are missing the first 4 homework assignments for Module 3. So that's where I think you should put your energy. There are a few of you who are up to date, though. So I'm going to go ahead and go to the end. So we're going to finish this lesson tomorrow, but this is the homework. This is homework 19. So let's use the rest of this time to get tutoring, get your questions answered on homework.